Let's look at some examples of some molecules and see if we can determine if we have any chiral carbon atoms on it and if we have a potential stereocenter. So let's take a look. Let's do this first. So what about this molecule? Well, this molecule has CH3, it's a CH2, CH2, and a CH3. So with 3 H's, that's not a possibility. And 2 identical atoms, not a possibility either. So this has no stereocenters. Okay, let's look at another one. What if we do this? What if we take that molecule, but we put a methyl group sticking off of that carbon? Well, here's what we can do real quickly. So CH2 is not going to work for us. CH3 and a CH3 and a CH3 is not going to work. Well, what about this carbon? What about this guy right here? Well, what's on it right now? So let's draw it out. Here's a carbon. There's a CH3, an H, and a CH3, and then this group here is an ethyl group. So this has 1, 2 identical groups on it also. So this is not going to be chiral either. So achiral, and this is also achiral, no stereocenter. All right, well, let's see. What if we were to do something like this? If we put a chloro group here. Again, real quickly finding stereocenters. That's not one, that's not one, and that's not one, right? Remember, CH3s and CH2s are not going to be stereocenters. And what about this? Well, what's sticking off of this right now? Let's take a look at it down below. So that's a carbon connected to a chlorine and an H atom, and then a CH3, and then a CH2, CH3. So definitely a chloro's 1. That's a second group. And now just because these are both connected to carbons doesn't mean that they're the same. They have to be exactly the same. So this is connected to a CH3. And that's different than a CH2 CH3. So that's 4 different groups. So this little point right there that I started, that is a chiral center. All right, let's do another one. So what about this? So what do we get here? Well, let's look at it. So again, kind of going through it. That's no, 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 and no. And then this carbon right here is also a no because it has 2 methyls on it, right? So that has no chiral center either. What about this? This one's a little harder. What about this molecule? Again, let's go through it so we can cancel some stuff out right off the bat. There's a CH3, that's not going to work. That CH3 is not going to work. That's not a chiral center. That's not a chiral center. This carbon in the middle, I don't know. Let's take a look at it. So a carbon here, that's connected to a CH3 and an H. So there's 2 groups at least right now. And now on this side, we're connected to a CH2 and a CH3. And on this side, we're connected to a CH2 and a chloro group. So those are different. This side here is different than that side. So this has 4 different groups. That guy right there that I starred is our chiral center. So hopefully you're feeling better with this. Now let's do some rings. So what about this molecule? Let's put here an OH group. All right, remember all the CH2s, right? None of those are going to work for us for being a possible chiral center, so we're going to X those out, right? And then this is a potential place, right? So that's connected to an H, so there's 1 atom. That's a different atom. But now in the ring, this atom and this atom are the same. This one compared to that's the same. Right, we're overlapping kind of twice right there. So because of that, this molecule only has 3 different groups on it. It is not a chiral center where that red little dot is. All right, let's do one more, guys. So what about this? What if I put an OH here, and then how about an iodo group right there? Well, let's look at it. Remember, we can already just cancel out these. Those aren't going to be chiral centers because they're all CH2s. But this position here is something to be concerned with. Right, so that has an H, so that's 1 group, 2 groups. Right, and now as we go this direction, that's a CH2 that's right here. And now we're going to compare that to this side, which is not a CH2. So that carbon right there is a stereocenter. And what about this other guy? And I'm going to redraw this because it got kind of messy. So let's take a look at it. Your OH here and your iodo group. So remember, there's an H that's there. So right off the bat, 1, 2 groups. And I think you can see where we're going here. That's a carbon connected to an OH, and that's a CH2. So those are different. That has 4 groups on it. So this molecule here has 2 stereocenters. Now as we go through some more examples, we'll have to identify these, and then we're going to have to figure out how to name them. And that's our next little section here.